Let's do Brahmanad. Om. Om. Shanti. 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 Swastha. Good morning, student. Now I am going to explain about a new chapter, that is your chemical bonding and molecular structure. Chemical bonding and molecular structure. What is the meaning of chemical bonding? ओडिया रे आमे रासायनिक बंध बोली करिथाउ. Then what is the meaning of chemical bonding? What are the cause of chemical bonding? आमे जदि गोटे atom रो stability विषय कहबा, generally we think about the electronic configuration. For example, आमे जदि sodium कथा कहबा, sodium having atomic number 11, the electronic configuration of sodium is 281. From the valence cell, we decide that whether this atom is stable or not. If the valence cell having 8 electron or 2 electron like the helium, then the atom is said to be stable. That means the atom must obey octet rule or dualite rule. If an atom having 8 electron or 2 electron like helium, then that atom is said to be obey octet rule or dualite rule, and that is considered as stable. Suppose an atom is not stable. That means that atom wants to stable. Then it can be possible by chemical bonding. There are 3 ways for an atom to make himself as stable. First is your gain of electron. Second is your loss of electron. Third is sharing of electron. By these 3 ways, an atom can attain its stability. When the atom follow any one of the 3 ways, then it must come in contact with the other atom. Suppose sodium wants to stable, then suppose it come in contact with the chlorine. Then what will happen? The nucleus of sodium attract the electron of the chlorine. On the same time, the nucleus of chlorine attract the electron of sodium. The nucleus of sodium attract the electron of chlorine. The nucleus of chlorine attract the electron of sodium. On the same time, the electron of sodium will repel to the electron of the chlorine. On the same time, the electron of chlorine repel to the electron of sodium. There are 4 forces will be arises, just like between nucleus of sodium and electron of chlorine. On the same time, nucleus of chlorine and electron of sodium and electron of chlorine repel to each other. We can think about the electron of chlorine and electron of sodium. Here 2 repulsive force and 2 attractive force will be possible. As a result, we think about the net force. The net force is your attractive force. This attractive force is called chemical bonding. That means chemical bonding is nothing but it is one type of attractive force. The attractive force that holds the constituent particle close together in a chemical species is called chemical bond. ये जो atom भितर जो attractive force रहिला ताको हमें chemical bonding बोली कहिथाओ. सेमाने काहेकि chemical bonding करिथांदी to maintain their stability. केमिति stability करिवे by the help of three way. One is a gain of electron, second is a loss of electron, third is a sharing of electron. Then we can conclude that why the atoms wants to make chemical bond. There are many causes for chemical bonding. First is to attain the inert gas configuration. First cause is to attain the inert gas configuration. Second is to result net attractive force. किस संदर्भରେ ଆମେ କହିଲେ ଯେ ଚାରୋଟି फोर्स क्रिएट होଉଛି. R न्यूक्लियस को I इलेक्ट्रॉन ଭିତରେ attraction, R न्यूक्लियस को I इलेक्ट्रॉन ଭିତରେ attraction, I इलेक्ट्रॉन ମଧ୍ୟରେ repulsion, I इलेक्ट्रॉन ମଧ୍ୟରେ repulsion. ए टोटल जो रिपल्सन अट्रैक्शन मिसेले हमको फाइनली अट्रैक्टिव फोर्स मिले. तेणु सेता पाइबा पाई आमे केमिकल बॉन्ड करिथाउ. फर्स्ट कॉज इज टू अटेन द इनर्ट गैस कन्फिगरेशन. सेकंड कॉज इज टू रिजॉल्व नेट अट्रैक्टिव फोर्स. थर्ड इज टू लोअरिंग ऑफ एनर्जी. एज ए रिजल्ट द नेट फोर्स इज अट्रैक्टिव. रिमेंबर वेरी important point. Remember and very important point. More is the energy, less is the stability. More is the energy, less is the stability. Less is the energy, more is the stability. Suppose गोटे मॉलिक्यूल हो बा एटम हो अधिक स्टेबल केते बेले हे परिबो जेतेबेले तार एनर्जी निजस्व कम हे परिबो. कम भाई निजर एनर्जी कम हवा अर्थ इलेक्ट्रॉन एनर्जी कम. इलेक्ट्रॉन एनर्जी यदि कम ताले इलेक्ट्रॉन रा इजीली न्यूक्लियस चारिपटे रोटेटिंग करिवो विदाउट एनी हेजिटेशन. So remember, more is the energy, less is the stability. There are three causes of chemical bond. One is to attain inert gas configuration. Second is to result the net attractive force. Third is to lowering of energy. As a result, the net force is attractive. Next, I will explain about the electronic theory of valency electron. That means by this theory we can able to think about the importance of valence electron. What are the role of valence electron? First point is the presence of 8 electron in the valence shell of an atom like that of noble gas constitutes the stable electronic structure of an atom. गोटे atom रो बाह्यतम कक्षरे यदि जो valence shell रे 8 electron रहले ही हमें से एटम को स्टेबल बोली कहिथाओ. सेकंड पॉइंट, द कैपेसिटी ऑफ एन एटम टू टेक पार्ट इन ए केमिकल कॉम्बिनेशन इज डिटरमाइंड बाय द नंबर ऑफ वैलेंसी इलेक्ट्रॉन. गोटे एटम रो वैलेंसी इलेक्ट्रॉन रे जेतोटी इलेक्ट्रॉन अछि ताकू धरि कि हमें केमिकल बॉन्डिंग करिथाओ. फॉर एग्जांपल ऑक्सीजन हैविंग इलेक्ट्रॉनिक कॉन्फिगरेशन 2 6. Atomic number of oxygen is 8. The electronic configuration is 2 6. From this valency electron, we can decide the chemical bonding of oxygen atom. Similarly, think about sodium. The atomic number of sodium is 11. The electronic configuration is 2 8 1. From this electron, we can decide the chemical bonding of sodium. Third point, during chemical combination, the transfer of one or more valence electron from one atom to another or mutual sharing of valence electron among themselves takes place. आमे यदि chemical bonding कथा कहबा ए valence electron ही एकरे sharing करिवो otherwise नाले gain करिवो और loss करिवो. এই ভ্যালেন্সি ইলেকট্রন লস হবো কিংবা অন্য কারো ভ্যালেন্সি ইলেকট্রন গেইন করব এই সোডিয়াম আটম किंबा ए इलेक्ट्रॉन ही सी शेयरिंग करिवो मन रखो वैलेंस इलेक्ट्रॉन ही शेयरिंग करा जाए वैलेंस इलेक्ट्रॉन ही लॉस करा जाए अन्य कार वैलेंस इलेक्ट्रॉन को ही गेन करा जाए नेक्स्ट पॉइंट द नंबर ऑफ इलेक्ट्रॉन which an atom loses or gain or mutually share to attain noble gas configuration is called its valency गोटे एटम रो वैलेंस इलेक्ट्रॉन केतोटी लॉस कला केतोटी गेन कला बा केतोटी शेयर कला ताकू नै कि आमे गोटे एटम रो वैलेंसी डिसाइड करि थाओ these are the importance of valence electron which is clearly explained by the help of electronic theory. Next I will explain about the types of chemical bonding. The chemical bond can be classified into three types such as number one is your electrovalent bond. This is also called ionic bond. It is also called heteropolar bond. Second is covalent bond. Third is coordinate bond. There are three types of chemical bond. There are also three types of physical bond. These are the chemical bond. There are also three types of physical bond. Such as number one is your hydrogen bond. Number two is your van der Waals force. Number three is your metallic bond. Let me explain about the electrovalent bond. What is the electrovalent bond? किसम पूर्व मु तुम कहली गोटे एटम टे एक इलेक्ट्रॉन लॉस करि परिबो बा गेन करि परिबो बा शेयर करि परिबो पले इलेक्ट्रॉन लॉस करे अर्थ आउ जने गेन करिया मु किछि मनी लॉस कली ता तो मो मनी जो लॉस हला आउ जने किबे पाइला से बळिया गोटे एटम किछि इलेक्ट्रॉन लॉस कला अर्थ सेई जो लॉस इलेक्ट्रॉन को अन्य कोनोसी गोटे एटम गेन कला फॉर एग्जांपल आमे सोडियम कथा कहबा sodium having electronic configuration is your 2 8 1 suppose हमें chlorine कथा कहबा chlorine रो electronic configuration कोन 2 8 7 सोडियम कोन करियो गोटे इलेक्ट्रॉन लॉस करियो आ से जो गोटे इलेक्ट्रॉन लॉस को के गेन करियो ना क्लोरीन गेन करियो जापाने कौन बुझिलो there is a transfer of electron from one atom to another atom this is your called electrovalent bond जो हमें कहले इलेक्ट्रॉन लॉस करबा बा गेन करबा बा शेयरिंग करबा से जो लॉस गेन द्वारा जो बॉन्ड क्रिएट होई थाए ताको हमें कहि थाओ electrovalent bond or ionic bond. Then what is the meaning of electrovalent bond? The bond which is formed by the transfer of one or more electron from one atom to another is called electrovalent bond. When these atoms approach each other, then what will happen? Sodium atom transfer an electron from its valency shell by ionization to the valency shell of chlorine atom which have more electron affinity. By such transfer of electron, sodium atom changes to Na plus ion and acquire the stable electronic configuration of neon atom because neon having electronic configuration 2 8. On the other hand, at the same time, chlorine atom gain this one electron and attain the stable electronic configuration of argon. Argon having electronic configuration 2, 8, 8. Now these two ions, that means Na plus and Cl minus ion, attract to each other by electrostatic force of attraction, which constitute the ionic bond between Na plus and Cl minus ion. When Cl gain one electron, then it is converted into Cl minus ion. When Na plus loses one electron, then it is converted into Na plus. Now Na plus and Cl minus attract to each other to form the ionic bond. Here loss of electron takes place, so we generally think about the ionization. Here gain of electron takes place, so we generally think about the electron affinity. Let me explain by diagrammatical representation. In case of sodium, one electron present in the valency shell. Suppose this electron is represented by cross mark. 7 electron present in the valency shell of chlorine atom. These electrons are represented by dot. Here the valency electron of sodium transfer to the valency shell of the chlorine atom. As a result, what will happen? Now Na plus will be formed. On the other hand, Cl minus ion will be formed. Here now 8 electron present in the valence shell. This electron now present in the valence shell of the chlorine atom. Now this plus ion and this minus ion will attract to each other to form a ionic bond. The other example like NaCl are CaCl2, KCl, MgCl2, K, K2O, MgO, Na2, MgS. These are the examples. Next I will explain about the condition for ionic bond. What are the conditions for ionic bond? First point is ionic bond is formed between two dissimilar atoms. Out of these, one is metal, another is non-metal. For example, we think about the NaCl. NaCl made by two atoms. Out of the two atoms, sodium is the metal, on the other hand chlorine is the non-metal. So first condition is ionic bond is formed between two dissimilar atoms. Out of these, one is metal, another is non-metal. Second condition, the metal atom must have low ionization energy. The sodium atom must have low ionization energy because the sodium atom can lose the electron when it has low ionization energy. Low ionization energy हेले ही एठारो शीघ्र इलेक्ट्रॉन लॉस करिवो आउ सेही जो लॉस इलेक्ट्रॉन को गेन करिया पई केले आरो बेसी इलेक्ट्रॉन एफिनिटी रहना दरकार ता अर्थ तमरा मेटल एटम रो लो आयोनाइजेशन एनर्जी रहिबो आउ नॉन मेटल एटम रो हाई इलेक्ट्रॉन एफिनिटी रहना दरकार तेनो नेक्स्ट कंडीशन हला द नॉन मेटल मस्ट हैव हाई इलेक्ट्रॉन एफिनिटी जेते शीघ्र बिले इटू इलेक्ट्रॉन एटी ट्रांसफर हो सेते तमरा स्ट्रांग आयोनिक बॉन्ड तयारी हो तार आर शीघ्र इलेक्ट्रॉन लॉस करिवार गोटे टेंडेंसी रहया दरकार आर शीघ्र इलेक्ट्रॉन गेन करिवार गोटे टेंडेंसी रहया दरकार शीघ्र केते बेले इलेक्ट्रॉन से लॉस करिवो जेते बेले आर लो आयोनाइजेशन एनर्जी थिबो ये शीघ्र केते बेले इलेक्ट्रॉन गेन करिवो जेते बेले आर मोर इलेक्ट्रॉन एफिनिटी थिबो Next condition is the lattice energy of the ionic compound should be high. Then what is the meaning of lattice energy? मन रखिले 1 mole रो आयोनिक कंपाउंड तैयारी करला समय रे जेतिक एनर्जी तमर रिलीज होउची ताकू तार लैटिस एनर्जी कहबा। द अमाउंट ऑफ एनर्जी लॉस when 1 mole of ionic compound is formed from its constituent ion is called lattice energy। ionic compound का कहबा बिले जोंठारे ionic bond थिबो, the compound which is made by ionic bond are called ionic compound। For the formation of ionic bond the lattice energy must be high। ता अर्थ बिले एठारे Na+ और Cl- जेतेले परस्पर पाखक आसंदी जेतेले NaCl कंपाउंड तैयारी हुए बाय द हेल्प ऑफ आयोनिक बॉन्ड। ए जो आयोनिक बॉन्ड कला समय रे अधिक एनर्जी तमर रिलीज हवा दरकार। कि सम पूर्व मु कहली बिले गोटे स्पीसीज रो यदि एनर्जी अधिक अछि ताले से अनस्टेबल, यदि तार एनर्जी कम अछि ताले से स्टेबल। देखो बिले ए दीटा एटम जेबले पाखापाखि आसंदी से माने गोटे इलेक्ट्रॉन लॉस गेन करंती परस्पर मध्य रे जा फल Na+Cl- तैयारी हुए, Na+Cl- मिश्रण NaCl तैयारी होइथांती। से समय मु तुमको कहूची जे ए दुईटी आयन जेते बॉन्ड तैयारी करिवे जेते अधिक एनर्जी रिलीज हेबा दरकार। यदि एमान ठन बिले अधिक एनर्जी रिलीज होला ताले एमान पाखरे कम एनर्जी रहला नै, आमे जानि जे एमान पाखरे यदि कम एनर्जी रहला ताले से माने मोर स्टेबल हेबे। कारण हमर प्रिंसिपल कोन कहूची मोर इज एनर्जी लेस इज स्टेबल। यदि एमान पाखरे यदि अधिक एनर्जी थांता ताले एमाने लेस स्टेबल हे थांते, तेणु एमान पाखरे कम एनर्जी रहबा हेले एमाने अधिक एनर्जी सराउंडिंग को रिलीज करबा दरकार। यदि एमान पाखरे अधिक एनर्जी रहिला ताले एमाने मोर अनस्टेबल हेबे। तेणु जेते से माने अधिक एनर्जी रिलीज करिवे सेते से मानकर स्टेबिलिटी बढ़िबो, कारण से मान पाखरे कम रहिबो। से माने अधिक रिलीज करिवे ता अर्थ निज पाखरे कम रखिवे। तो से जो रिलीज एनर्जी ता को हमें कोन कहउचे ना लैटिस एनर्जी कहताओ। लैटिस एनर्जी हाई होबा अर्थ से माने अधिक एनर्जी रिलीज कले, अधिक एनर्जी रिलीज करिया अर्थ से मान पाखरे कम एनर्जी रहिला, से मान पाखरे यदि कम एनर्जी रहिला ताले से माने more stable है। So we can think about that the other condition like this, the lattice energy of the ionic compound should be high। Next condition, the ion which will have participated in the ionic bond must be very small size। यार अर्थ है बिले हम जो NaCl तैयारी करिया पे व्यवहार करछि गोटे Na+ गोटे Cl-। एई आयन मानकर साइज कम रहबा दरकार। कम में बिले एबे देखो सोडियम रो गोटे इलेक्ट्रॉन क्लोरीन को जीवो, मानकर क्लोरीन रो इलेक्ट्रॉन एटे अछि बुझा पड़छ नै, तो ताको टाणीबाटा जेति की कष्ट हबो एट रहले आ टिके सहज हबो ना नै। तार साइज एते हबो ये कोन करबो इ जो न्यूक्लियर फोर्स से टाइटली से जो आसुथिबा इलेक्ट्रॉन को धरि रखिबो। मन रखबिले द आयन्स which will have participated in the ionic bond must be very small size। These are the condition for ionic bond। Next I will explain about the characteristics of ionic compound। Suppose हमें NaCl विषय रे कहबा। NaCl रो कोन कैरेक्टरिस्टिक्स अछि। फर्स्ट पॉइंट हला पिले NaCl होजी गोटे क्रिस्टलाइन सॉलिड। टू टाइप्स रो पिले सॉलिड थाए, गोटे क्रिस्टलाइन सॉलिड आ गोटे एमोर्फस सॉलिड। ए दीटा टाइप रो सॉलिड मध्यरो NaCl होजी पिले क्रिस्टलाइन सॉलिड। सो फर्स्ट पॉइंट इज all the ionic compounds are crystalline solid। तो जानते बिले NaCl ला होजी हार्ड और रिजिड। तेणु हमें सेकंड पॉइंट कौन कहि परिया बिले all the ionic compounds are hard and rigid। Third point is all the ionic compounds possess high density। Next point is all ionic compounds have high Remember the next point, all the ionic compounds are good conductor of electricity in the solution or molten state, but they cannot conduct electricity in solid. Next point is ionic compound soluble in polar solvent and it is insoluble in non-polar solvent. What is the meaning of polar solvent? What is the meaning of non-polar solvent? For now, remember this point. Polar solvent means it gives ions. Non-polar solvent means it do not give ion. There is also another term, that is polar solute. Another term is also, that is non-polar solute. Polar solute means it gives ions. Non-polar solute means it do not give ion. Remember an important point, like dissolve like. That means like soluble in like. This means polar solute always soluble in polar solvent, non-polar solute always soluble in non-polar solvent. NaCl is a polar solute, so it must be dissolved in polar solvent like your water. Water is a polar solvent because it gives ion, that is your H plus OH minus. Kerosene is a non-polar solvent because it do not give ion. Like kerosene, also other non-polar solvent are like your benzene. It is an organic compound. Next is your alcohol, ether. These are said to be non-polar solvent. All the ionic compounds gives ion, that means they are considered as polar solute, so they must dissolve in polar solvent like your water. Next one is all the ionic compounds are non-directional. The reaction between ionic compounds in solution are very fast. These are the characteristics of ionic compounds. Next I will discuss about the covalent bond. The force of attraction which arises due to sharing of electron between the constituent atom is called covalent bond. ଆମେ ଆଗରୁ କହିଥିଲେ ଯେ chemical bond can be formed by loss of electron, transfer of electron and sharing of electron. Loss of and gain of electron means it indicate the ionic bond. Now we think about the sharing of electron. When the two constituent atom sharing its electron and both are attaining the stable electronic configuration of nearest noble gas, then in such case a force will create. That attractive force is called covalent bond. Types of covalent bond. Next I will discuss about the types of covalent bond. Covalent bond on basing upon electronic theory, on the basis of electronic theory, covalent bonds are of three types. One is your single bond, second is your double bond, third is your triple bond. Single bond denoted by this symbol. This is for double bond, this is for triple bond. Single bond is formed when the constituent atoms share of one electron pair. Then such type of covalent bond are called single bond. Similarly, the covalent bond which is formed by sharing of two pair of electron is called double bond. Similarly, the covalent bond which is formed by sharing of three pair of electron is called triple bond. गोटे इलेक्ट्रॉन पेयर कले सिंगल बॉन्ड, दुईटा कले डबल बॉन्ड, तीनटा कले ट्रिपल बॉन्ड. Let me explain about the single bond with an example. Suppose I will think about the formation of Cl2 molecule. The atomic number of chlorine is 17. The electron configuration of chlorine is 287. Look at that. Here 7 electron present in the valence shell. It needs 1 electron to attain the stable electronic configuration of nearest noble gas, that is your argon. This is your chlorine atom. Here 7 electron present in the valence shell. This is your another chlorine atom. Here also 7 electron present in the valence shell. When two atoms come in contact with each other, then they share 1 electron. That means like this. This is your one pair of electron. This sharing pair electron is possible by the contribution of 1 electron from this chlorine atom and the contribution of another electron by this chlorine atom. As a result, they make one pair of electron. That's why we can able to form single bond. Now this chlorine atom attain the electronic configuration of nearest noble gas, that is your argon. This chlorine atom also attain the stable electronic configuration of nearest noble gas, that is your also argon. For stable electronic configuration, it is bound to calculate this electron for this chlorine atom. For stable configuration of this chlorine atom, it is bound to calculate this electron for this chlorine atom. Look at that. 1, 2, 3, 4, 5, 6, 7, 8. That's why this chlorine atom make a stable electronic configuration. 1, 2, 3, 4, 5, 6, 7, 8. That's why this chlorine atom also attain the stable electronic configuration. This is the example related to the single bond. The other examples, each single bond will be possible. That is your H2, H2O. Next is your NH3, HF, etc. Next, I will explain about the double bond by an example, that is your formation of O2 molecules. The atomic number of oxygen is your 8, the electron configuration is your 2,6. We have 6 electrons present in the valence shell of oxygen atom. We are also 6 electrons present in the valence shell of another oxygen atom. When these two oxygen atoms come in contact with each other, then they share 2 electrons like this. Look at that. Each oxygen atom share 2 electrons to make double bond. This is your double bond, which is formed by 4 electrons, 2 electrons from this oxygen atom, 2 electrons from this oxygen atom. Look at that. This oxygen atom now attain the stable electronic configuration of neon. This oxygen atom also attain the stable electronic configuration of nearest noble gas, that is your neon. Neon having electronic configuration, that is your 2, 8. Now calculate the electron present in the. Now calculate the number of electron for the stable electronic configuration of oxygen. 1, 2, 3, 4, 5, 6. 7, 8. Now this oxygen atom attain the stable electron configuration of neon. Similarly 1, 2, 3, 4, 5, 6, 7, 8. That's why this oxygen atom also attain the stable electron configuration of neon. The other example in which double bond will be possible, that is your CO, SO2, CH2, double bond, CH2. These are the examples in which double bond will be possible. Next I will explain about the triple bond with an example, that is your formation of nitrogen molecule. The atomic number of nitrogen is your 7, the electron configuration is your 2, 5. Look at that. Here 5 electron present in the valency shell of the nitrogen atom. Here also 5 electron present in the valence shell of another nitrogen atom. When they come in contact with each other, then they share 3 electron for the formation of triple bond, like this. Now the triple bond will be formed between 2 nitrogen atoms. Look at that. This nitrogen atom attain the stable electron configuration of neon. There are 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. As a result, this nitrogen atom attain the stable electron configuration of neon. Similarly, we can think about this nitrogen atom, 1, 2, 3, 4, 5, 6, 7, 8. As a result, this nitrogen atom attain the stable electron configuration of neon. That's why both nitrogen atoms are in stable condition. The other examples in which triple bond will be possible are HCN, C2, H2, etc. Next I will explain about the condition for covalent bond. The covalent bond will be formed between 2 similar atoms or dissimilar atoms. For example, Cl bond Cl. This is an example in which covalent bond is found between 2 similar atoms. Covalent bond also found between 2 dissimilar atoms. For example, C double bond O, C double bond O. Look at that. This covalent bond is found between dissimilar atoms. The second condition is both atoms have been sort of 1 or more electron than the nearest inert gas configuration. Third condition is if both the atoms have been sharing 1, 2, 3 electrons, then single, double and triple covalent bond respectively would be formed. That means for single bond we generally need 1 pair of electron. For double bond we need 2 pair of electron. For triple bond we generally need 3 pair of electron. The fourth condition is there is always decreasing energy during the formation of a covalent molecule. Next I will discuss about the characteristics of covalent compound. The compound which contain covalent bond, then that type of compound is covalent compound. First characteristics is most of the covalent compound are liquid or gases. That means maximum covalent compound are present in liquid state or gaseous state. We know that covalent compound do not give ions, they only give the small molecules or atom. That's why the covalent compounds are considered as nonpolar solute. The nonpolar solute always dissolve in nonpolar solvent. That's why the covalent compounds are soluble in nonpolar solvent like benzene, toluene, etc. But they are insoluble in polar solvent like water. Third point is the covalent compound have low melting point and boiling point. Next characteristics is pure covalent compounds are non-polar in nature. Next is it have lower density. Next important point is covalent compound are directional. That means they have certain directional character in their structure. Covalent compound exhibit slow molecular reaction under ordinary condition. These are the characteristics of covalent compound. Thank you. Have a nice day.